1. Define cache and its importance. Lightning-fast memory. Picture cache as your computer's swift memory space. When you visit a website, it stores some key information there for a lightning-fast recall. Time saver. Think of it like having a bookmark in a book. Instead of searching the entire book every time, cache is like a bookmark for websites. It keeps certain information handy so your computer doesn't have to fetch it from the internet each time. This speeds up the process and saves time. Streamlined performance. When you click a link or revisit a site, your computer checks its cache first. If the information is there, awesome. It skips the longer journey of getting it from the internet, making everything run smoother and quicker. In simple terms, cache is your computer's quick reference guide, storing commonly used information to speed up tasks and make your computer time more efficient. 2. Difference between HTTP and HTTPS. HTTP. Sending a postcard. Imagine HTTP as sending a postcard. It's the way your computer communicates with a website, but the message is open for anyone to see along the way. Less secure. Using HTTP for personal stuff on a website is like sharing secrets aloud in a crowded room. It's not the safest choice, especially for private information like passwords or credit card details. HTTPS. HTTPS. Sending a sealed envelope. On the other hand, HTTPS is like sending a letter in a sealed envelope. It's a more secure method for your computer to talk with a website. The information is locked up, making it harder for anyone to understand even if they try to peek. Extra safe. So, when you spot HTTPS in your browser's address bar, think of it as a little padlock assuring you that your conversation with the website is secure. It's that extra layer of protection, especially important when dealing with sensitive information online. In simpler terms, HTTP is like postcards with open messages, and HTTPS is like sealed letters ensuring a more secure and private conversation. 3. How HTTP works. Asking for a web page. Think of wanting to see a web page as if you're asking for a menu at a restaurant. When you type a website address into your browser, your computer sends a request to the restaurant server. The server, acting like a helpful waiter, gets your request, fetches the web page, and brings it back to your computer. It's like the waiter bringing you the menu you asked for. Clicking and exploring. On the web page, you find clickable links, kind of like choosing different items on the menu. Clicking a link triggers another request to the server, and the process continues. Language of the web. Consider HTTP as the language your computer uses to talk to the restaurant server. It's an open dialogue where your computer asks for things, and the server responds with the information you want. Not so hush-hush. However, the tricky part is that this talk happens in plain text. It's similar to having a conversation in a busy cafe. Anyone nearby could potentially hear your requests and the server's responses. So, while HTTP is okay for regular stuff, it's not the best for confidential information like passwords. In simple terms, HTTP is like a chat between your computer and a website, where requests and answers are out in the open. It's fine for regular browsing but not the safest for private information. 4. Define DHCP and how it works. Think of a networking assistant. Envision you're organizing a gathering, and you have a friend who takes care of seating arrangements, snack distribution, and ensures everyone has what they need. DHCP plays a similar role but for devices on a computer network. Distributing device ID numbers. Devices on a network, like your computer or phone, require unique identification numbers called IP addresses for communication. DHCP automatically hands out these addresses, much like your friend assigning seats to guests at the gathering. Automated convenience. Without DHCP, it's similar to personally guiding each guest to their seat, a time-consuming and error-prone task. DHCP handles this automatically, sparing you the effort of manually assigning IP addresses to each network device. Temporary assignments. Consider the IP addresses provided by DHCP as temporary party invitations. Guests, devices, receive an invitation, IP address, for a specific duration. When they leave the network, exit the party, the invitation expires and can be given to someone else. Effortless networking. With DHCP, your network operates seamlessly. New devices entering the network receive their invitations, IP addresses, automatically, eliminating the need for you to manually manage each device. It's like having an efficient assistant ensuring everyone finds their spot and can interact without confusion. In simple terms, DHCP acts as a helpful assistant, automatically assigning unique ID numbers, IP addresses, to devices, streamlining the operation of your network without requiring manual intervention for each device. 5. Define local area network. Think of your living space. Envision a local area network as your living space, a personal zone where different devices come together to share and communicate. Devices in your space. In this living space, you have various devices like a computer, printer, smart TV, and phone. These represent the devices within a LAN. Invisible connections. Picture an invisible network cable magically connecting all these devices. Although you can't see it, there's a virtual connection enabling your devices to communicate with each other within the LAN. Sharing resources. Similar to sharing your Wi-Fi at home, devices in a LAN share information. For instance, your computer can send a file to the printer or stream content to the smart TV. Limited to close proximity. A LAN functions like a small, exclusive club, most effective when devices are near each other. If you step out of your home's Wi-Fi range, your device may lose connection. Similarly, a LAN works best within a confined area like a home, office, or school. Cozy network of devices. In essence, a local area network is like a cozy network of devices reminiscent of your home network where gadgets communicate and share effortlessly, creating a simple and close-knit environment. In simple terms, a local area network is similar to a friendly club where devices within a close vicinity, such as your home, connect and exchange information seamlessly, much like the devices in your home network.